Okay, now we have our ball moving around, but we want to be able to pick up some collectibles that we can place in the level. So let's go ahead and build our collectibles. I'm gonna hit Control Space to bring this back up. I'm gonna make a new folder. We'll call this pickups because later on we might want different kinds of pickups and collectibles might be one kind of pickup. I'm going to right click and we're going to create a new kind of blueprint class. Because we don't want to control it and it's just going to exist inside the world with its own functionality, we're gonna make an actor, and that's what an actor is. So we're gonna click actor. For actors, usually you want the naming convention of BP underscore and then whatever the actor is. We'll call this collectible. There's an argument to be made of IBLE versus ABLE. I've seen it either way. Personally, I like IBLE for the object collectible and ABLE for the property of is it collectible or not. Either way though, collectible with an I for me. I'm gonna hit save all. I'm gonna save the asset in case we crash. And now let's open it up. Let's give it a visual. I think I want to add a static mesh. We'll do a cube. So again, for this one, I'm just gonna add the cube basic shape just so that it's consistent with the tutorial. You could definitely add the static mesh component and then choose whatever mesh you want, or you could resize it or whatever, but this is the same one since there's multiple kinds of cubes inside of Unreal. I just want to make sure that yours doesn't appear too different than what I'm doing. So we're going to take our cube. Here's the thing. I'm going to show you real quick. I'm going to put this in the level. So compile, save, and we're going to take our cube, put it in the level just so that we can see it. And if I hit play, you're going to see how big this cube is. It's nice to be able to see it in reference in the game world before we resize it. But I know that this is going to be too big. So I'm going to put the scale at something like 0.3, 0.3, 0.3. Realistically, you would be using a custom mesh for this that you would import into Unreal, and you'd resize it before you export it out and bring it into Unreal. But because I'm using objects inside of Unreal, I'm just resizing the default one that it has. So just keep that in mind. You wouldn't typically resize the scale of the static mesh inside of Unreal. You'd want to do that before you export and then import. But in this case, I'm using the default, so I need to. All right, so I'm going to compile and I'm going to save. And in this case, I'm not going to make the cube the default scene root, and I'll show you why in a little bit. But for now, just keep it right there, compile, save. So at this point, you could just choose another material over here that makes your pickup look cool. But I want to show you really quickly what a material is, how you can define your own. It's a whole different system. So I'm going to come back over here, and next to my BP collectible, I'm going to right click and I'm going to choose new material. Now there's two things we're going to mess around with right now. We're going to mess around with materials and material instances. Materials are going to define the rules of how our object is rendered. And then the material instance is going to define the little variables that we can change and tweak and assign to things inside of our world. So we don't really want to make too many materials. We do want to make a lot of material instances from a material. And I'll show you the difference in a second. But first we need a material to define the rules. So we'll say m underscore, we'll call this pickups because we want all of our pickups to have this set of rules from one material, and then we'll make material instances for different colors and things. In a much larger game, you would have even fewer materials and you'd make like a really big one with lots of variables, but we're not going to get into that quite at this point. I'm more concerned that you understand the concept. So I'm going to save that and we're going to double click to open it up. Now, the first thing I want to do is to define a color. So I'm going to hold V as in Victor, and I'm going to click inside of my viewport right there, and you'll see that it named it because I was holding V. So let's call this color. Now, the hotkey V is actually making a color, but a certain kind of color called a param. Now, with a parameter like this is going to expose it as if it's a variable when we create our material instances. So in other words, we want to change the color for different versions of this material or instances of this material inside the scene. So we don't want to hard set that, right? We may want some pickups to be yellow and some to be orange or purple, which is why this is a parameter version of the color node. This will make sense in a second. If I plug in the top node into base color, that's just saying the combination of everything beneath it. And let's choose a default. I'm going to go over to the default value over here once I have this node selected. Click on the black and we'll just choose orange. That's fine. Okay. So we have an orange color. And usually for these kind of things, I like to do an emissive for like a pickup or some kind of interactable in the scene. So I'm going to do another parameter for a value, because what I want to do is I want to take the color and I want to multiply it by a strength and then plug that into the emissive. So one thing you could do is you could hold down the number 1 on your keyboard and click. This would give you a value that you can multiply by, but the problem is we can't change this because it's not a parameter. Right, we're just always using this number to always multiply our color by 1, which we could do. Let me show you. If I drag off of color, we type multiply right there, and we plug in our number like that, and then we plug into emissive color like that. You see it kind of glows some, but the problem is we may want some objects to glow a little bit and some to glow a lot, and we want to change that on an object by object basis. So I don't want to hard set that. I want to expose that as a variable, just like I'm doing with my color. So I'm going to need to make this a parameter. Instead, we're going to right click and we're going to search for scalar, which is a number parameter. And you see it has it selected right there. The reason I'm searching for this, there might be a hotkey, but just want to show you that there's a lot of stuff in here that you can find. And we're going to click scalar parameter, and we're going to call this emissive strength. This is very similar to making variables whenever you're building your blueprints. We're just choosing what to expose for the designer to change. So we have our emissive strength. Let's not default that to 0. Let's put that at something like 0.5 maybe. And we will apply and save. So we have our color parameter that they can change. We have our emissive strength as 0.5 default that they can change. And we're going to multiply this together to have our emissive color. I think that's a good basic starting point. So we'll save that. We'll minimize. And now we have our material instructions, but in order to apply something to our collectible, we want to make a material instance from these instructions. So I'm going to select my material underscore pickups, right click and go to create material instance. So this is making an instance of this material. So like one particular version. So I like to call this mi underscore collectible. We'll call it that. And you'll see it looks the same as our material. Let's go ahead and save. Anytime we make a new asset, I like to save it. Or double click it, and you see the 2 parameters that we created right here. If we check it, like click the little checkbox, we can change it. So I'm gonna change the emissive strength to 1. I'm gonna change the color. Well, I don't think I'm gonna change the color. Maybe I'll drag it over a little bit, something like that. Hit OK, save it. So this is the one that we're going to use. It's just pulling all of its instructions from this one. The reason we're doing this is it is much more optimized to assign material instances to things in our scene rather than different materials for every object. It is much less optimized, at least at the time that I'm recording this. We want to work with material instances and have those based off of a material whenever we can. So if I go back into my BP underscore collectible and I go to my materials and I want to assign my new one. So I know it's called mi underscore. You'll see there's other ones. So I'm going to say collectible. Okay, there we go. Mi underscore collectible. Okay, and this is my custom material. You can always take this further and look up other tutorials on how to do more complicated things in materials, but this is just a very, very brief introduction into that. So the next thing we're going to add is a box collision for our collectible, and let me show you why. This is our collectible right now. You see, typically in games, if we touch corner to corner, we would think of that as colliding. But in games, we want to give a lot of padding to our objects just to make it feel nicer and make the player feel more empowered. So we want to define a custom collision outside of the static mesh so that when they touch it, let's say right here, they'll pick it up, even if they didn't perfectly hit it. It just feels nicer for the players, and I'd rather control that as a separate collision box rather than have it be tied to the actual visual of the collectible, because maybe that will change later. We don't know. We want the box collision to be consistent. So let's do that. I'm going to open up my blueprint collectible. We're going to add a box collision, this one right here. That's fine. I'm going to make my box collision the root just because I like to keep the main physics objects closer to the top of the hierarchy. It just makes the gameplay a little more clear. So I'm going to drag that. And so now we have our box collision and our cube underneath it. So one thing we want to do though is make sure that our box collision is the one doing all of our collision functionality and not our cube. So I'm going to go to my cube and I'm going to turn off the collisions on my cube. Now, in a lot of cases, it wouldn't even matter because we would probably pick it up before we get to the cube, but depends on how fast we're moving. Let's just turn it off just in case. So on our cube static mesh, we're gonna go to collision presets. Instead of block all dynamic, we'll put this on no collision. Okay, perfect. Compile, save. We're also gonna check our box collision. So if we click on box and we scroll down, overlap all dynamic, this is what we want. So this basically says allow dynamic colliders like our player to pass through. We'll call that an overlap and get the notification without actually blocking it from moving. So overlap all dynamic is what we want. We'll keep that just like it is. And one more thing I think I'm going to do here is I'm going to add a rotator to my object, because if you saw when I hit the play mode, it's pretty still. It doesn't look like something I would actually want to pick up. But if we rotate it, it's communicating to the player, hey, this is interesting. This is important. Come touch this thing. So we're going to add a rotator component, come back into BP_collectible, click on add, go to, I think it's just called rotator. Let's see. Oh, rotating movement. There we go. Click that, select the component and actually give it a rotation. So by default, it's 180. I usually like a 45, 45, 45, something like that. And I think that's it. Let's save that, hit play, and we have it rotating. Okay, so we have our box collision and it's overlapping, we think, but we're not actually doing anything with it yet. So let's actually hook into the collision and make it work. So to do that, let's open up BP_collectible. We need to go into our event graph. And the nice thing about components is that we can reference these components on this blueprint inside of our event graph. So if I delete all this over here, if I select my box collision, you see how I could like drag it in there? We could pull off of it and do a lot of things with that, but I want to show you a little shortcut. If I select my box collision and I scroll down, these are some events that we can hook into that will respond whenever that event gets called. So if you select it, I want on component begin overlap, hit the little plus button. What this means is that when any actor in the scene overlaps this collision component that we had selected, then it will call this node. And we have a lot of options for things that we can do when this node gets called. We get sent a lot of information. One thing we can do is we can test if the player is the one that was overlapping this component, which is what we want. We want the player to pick it up. So I'll drag off of other actor. So remember, we're on the collectible. So the other actor would be the player. And we're going to get that other actor and actually detect if it is the player. So it equal. So we want to know if two of these actors are the same. So I'm going to right click and type get player pawn. So this is going to get the pawn actor that the player is currently controlling. And we are going to pull that in and test if these are the same. If the other actor is also the player pawn. And if it is, then we want to either do something, or if it isn't, then we don't want to do anything. So I'm going to take the result of this comparison, pull off and type branch, plug it in. Okay. And if these things are true, then we want to do something. And I'm just going to leave a little print statement here just to see if my code is working. Print string, we'll say collect. Okay, and then after that, let's just go ahead and destroy this actor, because once we collect it, we don't want to see it anymore. We'll do other things here later, but for now, we're just testing it. Compile, save. Okay, we should see collect and it should disappear. Perfect, collect disappears. So this is the basic framework for how we can collect our collectibles from our player in the scene. And then we'll just actually add the functionality once we have this working. So now we need to talk about where we can put our collectible count. Now there's a few different ways to think about this. If we go to our assets that we currently have, we have a pawn and we have our player controller. Now remember that the player controller exists in the scene as a representation of the player in the world. And the pawn are different things that the player can control. So one question you might have is, if I pick up things with the pawn, right, pick up a collectible, if I put that collectible count on the ball pawn, then if the ball pawn dies, then it doesn't exist anymore, right? So we could put it on the player controller, since the player controller always exists, not the player start, the player controller right here. We could put it on the player controller, and a lot of places do, and this would probably be fine for a single player game. But the other problem here is that the player controller is responsible for a lot of other things. And if we start combining too many random things onto the player controller, it's going to feel very bloated. The proper place to put it, if I open up the Unreal documentation over here, they actually tell you in the gameplay framework, you can find some documentation over here. This is the relationship of everything according to how Unreal is laid out. And they say that with a player state, any data that belongs to the player, so name, score, in-match level, or whatever, information that changes throughout the game, you should be storing this on the player state. Now, again, in a single player game, it's probably not going to matter a ton, but I'd rather us go through the proper way to set this up, just in case later on we want to expand it. And for this demo, we're going to use the player state to track those kind of things. Now, you also see that we could put in the game state, but that is supposed to be more general things and not information that changes a whole lot. So we'll use the player state in this case. One thing you're going to notice, if I try to right click over here in BallGame and go to Blueprint class, I can't see a player state, right? Once you start to create more specific kinds of classes, you may need to search for these. So I'm going to click the drop down. I'll type in player state down here, and you're going to see a couple of other things. We want the player state one at the bottom. I'm going to click that and hit select. And so this is creating a child class of the player state base object. And we'll call this BallPlayerState. Okay, and we'll save selected. So now we're going to hold on to our collectible count inside of the player state. We could hold on to other things as well later on if we expand it, lives, whatever. If you open this up, we're going to create a new variable over here. This is collectible count. So in other words, whole numbers. Collectible count, which means it's going to be an integer, and collectible count. Yeah, cool. Compile, save. Default should be 0. We're good there. I think that's all we need inside of our ball player state. Let's close that out. Now, the other thing, if you remember, if we hit the play button, one of the things that our level creates is a player state. We don't want that one. We want the ball player state, the more specific player state that we are creating and customizing. So to do that, we need to actually go back into our ball game mode, come over here under player state, and we're going to do the drop down, and we're going to change it to our more specific ball player state. Hit compile, save. And now when we hit play button, you see it makes a ball player state over there. Just verify that it is actually spawning the correct state that we're making inside the scene before you continue. And now that we have our collectible count sitting somewhere, then we can actually put a value into that variable. So now inside of our pickup, so if I go to my pickups, open that up, in place of this print string collect that we have, we really want to access the collectible account. Now, if I delete this right here, what I want to do is I want to get access to the ball player state and access the collectible count. So if I right click and type in player state, say get player state, this will give me access to the player state that is in our current game mode. The problem is we're getting access to the base player state, and we need the more specific ball player state that we created, right? We added a variable in this one, ball player state. So we need to cast so that we're not just using the generic player state, we're using the specific ball player state. And usually when you want to get access to a specific class, you need to cast. So pull off and say cast to ball player state. Just double check that name there, plug it in. And so now that we have access to the ball player state, we can pull off of that as the more specific object. And now we can get collectible count like that. Right, and we can do other things with that, but this is how we can cast to get that. So I'm gonna plug that back in right there. So now that we have access to it, we need to actually add our collectible to the collectible count. So there's a couple different ways you can do this. We could just increment it by 1. That would definitely be the easiest way, like pull off and say increment, right? We could increment it by 1. But in some cases, you want to add more than 1 to a variable. And I want to show you that version, which is just a little bit slightly different and longer. What we want to do is get access to the current count and then add an amount to it. So as ball player state, we get access to the collectible account. They want to add, so I'll pull off that and say add, and we need to add an amount. We don't want to add 0, we want to add 1. Now, if this collectible was worth 5, for example, we could, add 5, or we can make that a variable or whatever. But for now, we're just going to keep it 1. So we access it, we add 1, and then we need to set this as the new value, because otherwise we're just making a calculation. So we're going to pull off of our ball player state again and say set collectible count right there. And so this is actually an execution pin. We'll drag there and say set our collectible count variable to be this new one that we created. So the current one plus 1, set it. So we'll plug it in. One more thing I'm going to do here is I'm going to print string, and I want to print the current collectible count. So we'll just plug this right in there, just like that. We'll get rid of this later, but I just want to see it count up if I have multiple collectibles and I'm picking them up. Actually, let's disconnect this one. Since we're setting it to a value, let's print that one. I think that's a little bit more accurate. It's technically the same, but makes me feel better, I guess. We'll compile, save. And so now when we pick up a collectible, it will get the player state, get the specific ball player state, which is what has our collectible count, get access to it, add 1, set that as a new amount, and then print it and then destroy. Compile, save, minimize, and test it out. Oh, actually, let's, if you hold Alt, you can pull out a couple more collectibles like that. Okay, Control S to save and hit play. Now we should see the number count up. 1, 2, 3, 4, perfect. Okay, so I mean, this is the basics of adding to our collectible count and how to pull that into the player state, which I think is a better place to put it. That makes more sense rather than trying to combine it all on a single actor. It's just way too complicated. All right, so the next thing we want is we want to hear a sound effect whenever we pick up our collectible. So one thing you could do, just the fast version, is you could play the sound with an existing sound effect, which at whatever point in code we get, you'll see you can use any of the internal editor sounds just for testing. But I want to show you how you can import a new custom sound. And for me, I'm just going to do prototype ones. If you don't know Chiptone already, it's just a really handy website for grabbing. It'll redirect you, I guess. It's really good and quick for making prototype sounds. And for now, I just want to hear a sound effect. I can polish it later. So I'm going to click coin. I'll click it a couple times. Yeah, that one's good. Another trick is I like to turn on, where is it? Tremolo and delay. Right, it sounds a little bit better. Maybe arpeggio. Yeah, that's good. You don't have to spend too much time on this part. So I'm going to save wave. It'll put it out there. You just, wherever you save it, you can rename it. We'll say coin pickup. And then I'm just going to drag and drop it into the content browser over here. So let's make a new folder before we do that. So right click, new folder, call this audio. And inside of audio, we will drag and drop our coin pickup. It will do something. It'll minimize, it'll pull it in. You can test it here. Okay, pretty good. Let's save that. And you could just use this if you want, but I like to add a little bit of variation to the sound effects. And we can quickly do that by using sound cues. So if I right click my waves, this is just my base sound, and I go to create cue, this is going to make a special kind of asset. So I'll just hit enter, called a cue asset, where let's save that again. If you double click that, this allows us to add additional properties and features to our sound before we actually hear it in the game. One thing that I like to add is something called a modulator. So let's pull off of our sound wave that we're going to play and call this modulator. And I'm going to connect the output into the final speaker. This is what we hear. And this is our sound wave that we imported. If I click it, you can see right here. But on modulator, every single time we trigger this, it's going to give slight random variation to the pitch, just how high or low something is, and the volume, which is how loud or soft it is. So if I hit play a couple times, right, you can hear that. You can make it more subtle if you want, but it's just a really quick and easy way of adding some variation to your sounds. So I'll save it. And now we're going to jump into our blueprint again over in pickups, our BP_collectible. Okay, so when we are collecting, we want to play the sound and then destroy the actor. So one quick note here is we have two different ways that we can play the sound. We can play it as 2D, which means that the player will hear it. It'll just be rendered on top of everything. Or we can play it in the world. And I'm going to play it in the world. And you could imagine this as like, well, why would we want to do that? In a multiplayer game, you might want to be able to hear other players collect collectibles. Maybe if it's like online or something. For the most part, you want to play sounds inside the world unless they're things like button clicks or more subtle, less gameplay important sounds. So let's right click and type play sound at location. I mentioned the two different ways you could play this. Play sound at location. So plug that in, and we want to know what sound to play. So click the drop down. I want the coin pickup, the cue version, which has the additional properties in it. So the variation. And where do I want to play it? If I right click, I can get this actor's current location. So get actor location. I want to play it at the same location as this collectible pickup. So get actor location will get the location of the actor of the blueprint that we are inside of right here. So compile, save. Connect that. Okay, so play a sound at this actor's location, which is going to be our blueprint collectible compile, save. I think we're good there. Make sure that you have a sound selected. Again, I'd made a prototype one, but you could choose any one of these editor ones if you think one sounds better, or you can make your own. So we'll come back in here. Let's test it out. Play. Okay, pretty cool. It's working. We hear a sound effect when we collect our collectible. Another thing I think I want is when my ball is collecting these, I want to see a little burst, so some kind of visual effect whenever we collect our object. Usually it's nice in games to have a visual and an audio component for any time something important in the game happens. Just a good rule of thumb. So let's add a visual burst. It's also a good opportunity to talk about like a generic burst inside a Niagara system. Let's create a new folder called Particles. Okay, and inside of Particles, I'm going to right click and I'm going to go to FX, and I want a new Niagara system. So the difference here is an emitter is a small part of a Niagara system. The system is the final thing that's getting played, and the emitters are the different components inside of the system. So I just want to do a simple burst. So I'm going to click System, and I'm going to choose the top option, New System from Selected Emitters, and I want to scroll down and use Omnidirectional Burst. Hit the plus button to add this to our system, and then click Finish. Call this PS underscore for particle system generic burst. Okay, let's save our asset here. We'll open it up. Okay, once we have it open, you can see a little preview here that'll play every now and then. I'm not going to customize this hardly at all. I'm just going to open it up and I'm going to change the color. So if you scroll down, once you select your omnidirectional burst, click the white, and I'm going to move to make that look kind of similar to our pickup. Hit OK. And honestly, I think that's it. I think that's fine for now. We can always customize this later once we get it hooked up. So let's go back to where's our pickup here? BP underscore collectible. We're going to come over here, and similar to our sound that we created earlier, I'm going to right click and say spawn. So this one's just called spawn system. So spawn system at location. So you're going to see spawn emitter. This is using the older particle system, whereas Niagara system is the more complex, newer one. Spawn system at location or spawn system attached. We want to make sure that we do at location, just like our sound over here. Spawn sound at location, spawn a particle. Pull that up, drag that in, drag that out. Okay, so I want to choose a system. It's the one that we just created. Since we only have one, we'll choose that one. The location, we're going to do the same thing. I'll just copy paste this node. You could drag it in, but I like to keep things separate where I can. Drag in the location. We're not going to mess with anything else. You'll see that it will auto destroy when it's done. So it'll spawn, it'll play, and then it'll destroy itself. Auto activate just means that it will play the second it is spawned inside the scene. All that's good. I think that's it. Let's hit compile and save. Go back, save our scene, Control S inside of our map, and hit play. Perfect. Okay, it's simple but effective. It is just enough to make it feel exciting to pick up a collectible. So now we have our collectibles, they burst, they make a sound effect, but we're still using that print text over in the top. So we want to put that inside of a small UI widget that we can use to count up our collectibles. So let's do that. First, like the other things, I'm going to make a folder for UI. Let's see how quickly our folders will change once we start adding any kind of extras. We go to our UI, and I'm going to right click and go to user interface, create something called a widget blueprint. You can think of widgets as tiny little graphics that we can put all over our screen, just depending on what we want to track. In this case, we want to track our collectible count. I'm going to click this top button, user widget, the most common one. And Unreal recommends you name user widgets as W for widget, BP underscore, and then whatever the thing is. I'm going to call this player info. And the reason is because if I wanted to add additional things to this widget, I probably wouldn't want to make a separate widget for every single part of my UI. I probably want to put, let's say, health and collectible count and lives as one contained widget. So I'll just keep this as player info, something pretty simple. Let's save it and we'll open it up. Okay, now this is going to look a little bit different if you've never seen the designer view of your widget before. Just know that at the top right, you have a graph, which is what you're used to. We can add functionality to our widget as well if we want, and we will. And you have your designer view, which is where we can customize the look of it. So make sure you're in the designer view. And the first thing we're going to do is we're going to add something called a canvas component. Now the canvas is what allows us to render our widget onto our camera and we can like resize it and things. So if I type in canvas panel, this is our palette. This is our list of little features and things that we can attach to our widget. I want a canvas panel, so I'm going to drag and drop it into our hierarchy, which is what our widget actually is. So when you drag our canvas panel down here, this is our representation of our screen. We can do things to it, but we're really not going to mess with very much since it's just introducing you to these systems. So once we have our canvas, I'm also going to make a little graphic to represent our collectible cube over here. So let's go back to our palette, hit back. You can see that we get some defaults over here. Image is a pretty common one, so I'm going to drag this one down underneath canvas panel. So this is our image. Let's make this a box so that it looks like our collectible, our little squares inside the scene. Cubes, sorry, not squares. Just to make this very precise, I'm going to change this to 50 on my size X and size Y. If I zoom out a little bit, this is roughly what it's going to look like. You're going to see this little flower looking thing up here. It's telling us where we want to anchor this to in case our screen changes a bit. We want to make sure that it's anchored properly. Honestly, to start off, just anchor things to the nearest corner and you're usually fine. And we'll actually position the anchor so it's more specific, 60 and 60. So 60 units from the anchor position, which is this top corner, so we can space it out evenly there. Let's also change the color of this image. We'll make it match. Long term, you would import a graphic or a sprite or something and give it a nicer look. But for now, I'm just using placeholder shapes and things. So this is fine. Let's compile, save. So now we need a number to represent the collectible count. And we'll put that right next to our image over here. Let's find text is what we want. So let's drag down text. And we'll put that underneath the canvas as well. We can resize this a bit. Really, you can eyeball it. You can always reposition things more precisely later. I like to just round it off the nearest thing. That is fine. I'm going to change the text block to something like 0, so it's more accurate to what our number spacing is going to be, maybe 0, 0, 0. Okay, we have our look of our widget. Now, just because we have a number here does not mean that that is accurate, right? So what we want to do is tie this number to the actual collectible count inside of our BallPlayerState. I'm going to close some of these tabs out too, ones that we don't need anymore. We want to attach this number to our actual collectible count. We would refer to that as a binding. We are going to bind this part of the UI to a variable somewhere. In this case, the collectible count inside of the BallPlayerState. Oh, let's do one more thing before we do this. Let's name these. So we'll call this collectible icon and we'll call this collectible count text, something, doesn't really matter. And we're going to create a binding on the content text 000, this one that we put earlier. If you click the drop down, we can create a binding. So click this button and a lot of things are going to happen. It's going to look kind of scary, but all it's doing is it's creating a new function for you that allows us to get a value, and this will plug it into the UI widget and it'll update that little count to represent whatever value we put into here. So when we get the collectible count text object, it wants to know, well, what is the actual value so that I can actually change it and assign it to it. So we can keep these the same. So we need to give it the collectible count into this node. Now, here's the problem. How do we get the BallPlayerState and get the collectible count and put it into here? Well, we saw a way to do that earlier. I'm going to show you this, and we're going to move it to a better place. We can get the player state. We can then cast it, just like we did before. Cast it to the BallPlayerState because we want the specific player state, right? The one that we created, not the generic default one. And from that, we can get the collectible count, okay? And we could plug that in, just like that. And this would probably work. Now, the problem here is that every single time we want to update the collectible count text, we are having to do a search and then doing a cast and then doing some interpretation of it. Whereas I can find this once and I can reuse it. I don't need to continually find this every single time I want to change this text or I want to modify it. So I'm going to recommend that, oh, and if I hit the save button up there, you can see another problem. Our cast needs to come through here like this, right? In order to do that, compile, save. There's a better way to do this, and it's using something called caching, where we are going to get our reference at the beginning, and then we're just going to reuse that whenever we need it. We're going to save it off into a variable and then use it when we need it instead of doing a search every single time we want it. It's just going to be way more efficient. So to do this, there's a event construct. This is very similar to begin play on other actors. but this is when we create the widget. So what I'm gonna do here is I'm going to double click event construct so you can see it. If you wanna get back to your function and you close this window, it's just this function over here like that. So back on event construct, what we're going to do is we're going to create a reference to the BallPlayerState, and we're going to save that into a variable. So let me come back into the function. We're going to grab all this stuff here. I'm going to hit Control X to cut. I'm going to bring it over here and paste. Okay, so on event construct, get the player state, cast it, and then we don't need this part right here. Once we get it, I need to store this into a variable. Now you could create the variable and reassign it and set it and whatever. A faster way of doing that is to right click the BallPlayerState, this output. So this is the specific one we want, the BallPlayerState. Right click and say promote to variable. So this will automatically fill in the set node and it'll save this one, create the variable for me under variables. And I'm going to relabel this just BallPlayerState. Just make it more clear, compile, save. So now we've found it, we can save it, and we can reuse this whenever we want because we're doing this right when the object is created. Now, this will work as long as we're not changing what our player state is at runtime, right? We don't have different kinds of ball player states, but that's usually not very common, so this is pretty safe to do. So I'm going to go back to my function over here, and now we don't have to search and find it. We just pull off of BallPlayerState, we say get it, and we've already found it. We're just using the thing that we saved off. We pull off and we say get CollectibleCount, and we still need to convert it, but that's fine. Pull that in, put it over here, reorganize, plug that in, pull it over. Okay, perfect. Compile, save. So again, we're just doing this to be a little bit more optimized, but it's a chance for me to talk about better practices. So now that this is all working, if we go to designer view, this will update in the game based on our collectible count. So when the collectible count changes, this UI will respond and we'll see that number just plugged in because of this binding function that we created, right? And then at the very beginning, it's going to get our ball player state, assign it so that whenever we get it, we can just look at the collectible count. All right, so we're not done yet. We're very close. All we need to do now is we need to assign it to the viewport, because if we hit play, it's not creating the widget because it doesn't know that it needs to. We could have all different kinds of widgets. So I'm gonna hit escape. We need to create the widget at a certain point in time. Now, you may consider if you want this on the ball pawn or the player controller, like when is this widget created? If it was a very specific widget specific to the ball pawn, then you might want to do it from the ball pawn. For me, because I might have different kinds of pawns that all collect the same kind of collectibles, to me, it makes sense to put it on the player controller. So I'm going to open that up. I'm going to go to the event graph. Again, the ball player controller. On begin play, we want to create the widget. So we're going to create the widget and then assign it to our viewport. I'm going to delete the event tick. We don't need it. Begin play, we'll pull off and say create widget, create widget. And then we need to assign the widget that we want to create. What is the widget class? And it is the WBP underscore player info. Perfect. Owning player, if you hover over, this is looking for a player controller. I believe if you leave this empty, it'll be fine. It'll assume you want the one this is connected to. But just to show you, if you want to be safe, or if you ever want to reference the same class that this blueprint is in, we can use something called self. So type in self. Get a reference to self. This is just saying I want access to this player controller that we're inside of. So just a little handy thing that if you didn't know about. And then once we create the widget, we've created it, but we haven't assigned it to anything. We want to assign it to the viewport so it's actually being rendered. So we're going to pull off of return value and type add to viewport. Okay, and then it'll automatically connect it up. Now that we've done this, I think it'll work. We're creating it and assigning it to the viewport. We've done our binding. Let's try it. Okay, cool. We're pretty close. We just need to get rid of that print string so that we don't have that in the way. So open up our collectible, come over here, delete the print string, connect that in. I'm just going to reorganize that a little bit. And there we go. I think it's all clean now. Okay, so basic collectibles. So if you want a little optional challenge to kind of practice what we've been learning, my recommendation is try and create another collectible, like maybe a rare collectible, but make it different, give it a different count as part of your UI, make it a different color or whatever. I'm not going to actually walk through how to do that because it would just be a repeat of what we just did. But it's good practice for you to make sure that you can start to learn the stuff and practice on your own. So I do recommend making a little rare collectible to reinforce everything that we've just learned.